Today we're going to go over transformations of square root functions. And so to start that, let's review the parent function that we learned in the first unit, which is the square root of x. If we take the square root of 0, so I plug in my 0 here, the square root of 0 is 0. We focus on the perfect squares so that we don't have decimal approximations to graph. So my next value would be 1, and the square root of 1 is 1. The square root of 4 is 2, and the square root of 9 is 3. So these are going to be my key points when I'm graphing any one of the transformations. I start with those. So let's put those on my graph here. 0, 0, 1, 1, 4, 2, and 9, 3. And so we connect the dots and we get a graph that looks like that. All right, and so it says, what do you notice about the graphs that are less than 0, and explain why this happens? So let's put this in our calculator so we can practice that at the same time and see what happens there. So I take the square root of x, so I'm going to put the square root in there of x, and I'm going to go to my table of values here. And so when I look at that, I see the ones that we just did, 0, 0, 1, 1, 4, 2, and 9, 3. But if I go into the negative side, notice it says error. That's because when we put a negative number under the square root, it is not a real number. It's an imaginary number. And so we don't graph that on our regular XY coordinate. So they are not on this graph. A negative number under the square root is an imaginary number. All right. So what is the domain and the range of this? Well, we start right here. This is the first x value, the one that has 0. We just said negative numbers are going to say error in the calculator. They're undefined for this graph. So 0 is my first point, and there is a point there, so I'm going to include that with a bracket. Remember when we write our interval notation, I need a bracket because I'm including 0. And then it goes on forever, so I'm going to have infinity there. Same thing's going to be true for my range. Since the square root of 0 was 0, that's going to be my first y value, and it goes up forever. And we are including that 0, so again, we have a bracket. All right, so we're going to start looking at some of these transformations now using that parent function. So it tells us to fill in the table for y equals 2 square root of x, then graph. Notice that the x values are still there. Remember, everything outside of the operation affects our y values, and everything inside of the operation affects our x values. Since there's nothing inside the square root with the x, then x's stay the same. We're going to then multiply our key points by 2 because that's what that vertical stretch is. This right here is a vertical stretch. I multiply my y values times 2. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4, and 3 times 2 is 6. And so I'm going to graph those, and I get 0, 0, 1, 2, 4, 4, and 9, 6. And so now my graph is steeper than the parent function. So here's the parent function. Here is my new graph. It is steeper. That is a vertical stretch. We took it like this and just pulled up. So we've got a vertical stretch by 2. All right, what happens when the a value is negative? So if this value was a negative here, we've talked about that being a reflection across the x-axis. So each one of these values would be multiplied times a negative because we would have multiplied our y's here. So we would have been at 1, negative 2, and 4, negative 4. So it would be a reflection across that x-axis. All right, on the inside now, we said that affects our x values. When we multiply times a negative like this. So we have gone ahead and multiplied some of these y values, some of these x values times a negative, so you can see how that changes our equation. If I put a negative in here now, then the negative times the negative gives me a positive, and so the square root of a positive 4 is 2. So the negative signs cancel each other out. And so if I put a negative 1 here, negative, negative turns that into a positive 1. 0 is neutral, so we'll keep that as 0. However, if I put a positive 1 in here, that's going to become a negative 1 inside the square root, and that's where we see that error or undefined value. So if we graph this one, we end up with 0, 0, negative 1, 1, and negative 4, 2. And if we look at this graph compared to our parent function, so here was our parent function, and then here is our new graph, we see that it has reflected across the y-axis. So this is one of our functions, the ones that we've dealt with, we dealt with absolute value first and quadratic second. That reflection across the y was not seen on the graph because it was symmetrical across the y-axis for our parent functions. But this one here is not. So we do see the difference between a reflection across the x-axis and a reflection across the y. A reflection across the x is going to look like this. A reflection across the y is going to look like this. And so that's a good place to tell you, remember not to just write reflection, you have to write what the reflection is across. Is it across the x-axis? Is it across the y-axis? All right, so with both our absolute value and our quadratic unit, we have filled out the transformation summary. So I'm going to go ahead and fill it out for you again. It does nothing different than what we have talked about. The A value is my vertical stretching, compressing, and reflection across the x. My B value is the reflection across the y-axis, and it affects my x values because it is the horizontal stretching or compressing. C is my left and right movement, again affecting the x values, and then the D is outside of the operation, so it is up and down. And when I say inside or outside, the operation in this particular one is the square root. So all of the horizontal stuff falls inside the square root, and then my vertical stuff falls outside of the root. So I'm going to go ahead and pause this video, fill out this chart for you. I don't want to waste through the time of the video. So there you go. There's that chart again with all of those transformations. Again, every function we deal with all year is going to have the same transformations. These are the same transformations you're going to see next year too in pre-cal. They do not change. The only thing that changes in each one is the operation, and that's going to tell you which parent function to start with. All right, so the next part is the easier of the questions that should be getting easier at this point in the year is to list the transformations when you see them in an equation. And so right here, it's important to point out that this is factored, so it's ready to go. If it was not factored, if there was something in front of the x, you do have to do that first before you start doing your transformations, because this is the transformational form. It should have nothing in front of the x. So we have a transformation for each one of these. And so you want to make sure you point out all of the transformations. So 4 is inside the square root, so that's going to be horizontal. It is greater than 1, so it is a compression by 1 over 4. It's good to look at the scale factor to determine if it's a stretch or compression. If the scale factor is a fraction less than 1, then it is a compression. If it is bigger than 1, it is a stretch. That is true for both, so that's why it makes it a little bit easier if you look at the actual scale factor. And so the inside part needs to flip, and so that scale factor is 1/4. When we talk about the outside one, the A, it does not flip. It is that number. So whatever number's here is the factor. Where B, it is 1 over B, so you have to do the reciprocal. This would be left 1, and then this would be up 2. All right, I'm going to pause the video and put these. You go ahead and pause as well and see if you can come up with all the transformations that you should know at this point. All right, check your work. Hopefully you got all of those transformations correct. Those are the ones that are going to be easier questions on the test at this point. The next easier ones are going to be the ones that give you the transformations and have you write the equation. So let's try that. It says write the equation of a square root function that has been reflected over the x-axis, shifted right 1 and down 3. So it gives us this information so we know which operation to do. We want it to reflect over the x-axis, so I need a negative on the outside. And so then we would have our square root to show right 1. That's going to be an x minus 1 on the inside of the square root. And then down 3 would be a minus 3 at the end. For our next one here, it wants us to write the equation again of the square root function. Anytime it says write an equation, you know you have to have a y equals or an f of x equals because that's what makes it an equation. Now this one has a reflection across the y-axis, and so that is a negative on the inside. I like to put this in the factored form. It makes it a little bit easier, so I'm going to have a parentheses here, and then left 2 tells me to do plus 2. If you leave out these parentheses, then you are not going to the left 2. So it is really important to have it in that factored form. And then up 3. All right, the questions that are a little bit harder is the ones that you have to actually graph. So first off, you want to make sure you know that parent function really well. And so that's 0, 0, 1, 1, 4, 2. There's my parent function. That's where we always start. And then we're going to apply the transformations that are here. And so we've got a vertical stretch by 2. We have a left 3, and then we have a down 2. So we're going to apply all 3 of those transformations. Now the left 3 is the only one that affects the x. And then my vertical stretch by 2 and my down 2 affects the y. So I'll go ahead and show you how to do that with 1 point. I'll do it with the 1, 1 point because it's a little bit easier than, or a little bit, it makes more sense than doing it with the 0. So if we are going to apply the transformations to this, we said this is the one that's going to affect our x value. And so we are going to go from 1 to the left 3. So that would put us at negative 2. We are at 1, left 3. That puts us at negative 2. I subtracted 3 from this one. The y value is going to be affected by these 2. And so we start with our vertical stretch by 2. So 1 times 2 is 2. And then we're going to go down 2. And so that puts us at 0. So let's try that again. That's this point right here. We vertically stretch it by 2. So I'm doubling it. So it's going to be right here at 2. And then I'm going to go down 2. And so that point is right here. Then we would do our left 3, 2, 3. And there it is at negative 2, 0. So I'm going to go ahead and graph this now. And I'll start with the 0, 0 point just so that we can do the whole thing. So when I multiply 0 times 2, that is still 0. And then I move to the left 3 and down 2, and here is my first point. Our second point we already know is at negative 2, 0, because we had already done that one here. My third point, which is at 4, 2, I stretch it by 2, so it goes to 4, 4. So it was right here. I stretch it by 2. I'm doubling it. And so it comes right here. And then I move it to the left, 1, 2, 3, and then down 1, 2. And so my new graph looks like this. If you prefer to do it with the points, do each point individually like this with your transformations. That will get it. If you prefer to do it off the graph, you can do it that way, but you do have to take into account all 3 transformations to the parent function. All right, for our domain, the smallest x value here is at negative 3. There is a point there, so I'm going to have a bracket, and it goes on forever, so this would be infinity. For our range, negative 2 is the smallest point. There is a point there, so I'm going to have a bracket, and it goes up forever, so that would be 2 to infinity. All right, let's try another one of those. Graphing is the harder part. For this one here, before I get started, I'm going to have to factor that negative out. We should not have anything in front of the x in our transformational form. So my first step is to factor that out. Now a negative times x gives me that negative x, and a negative times a negative 4 gives me that positive 4. And then I have this plus 2 at the end. All right. Time to get this graphed. So we're going to start with our parent function of 0, 0. If I reflect that across the y, it doesn't do anything because it's on the y-axis. But I can move it to the right 4 and up 2. So I'm right here. And I forgot to write those transformations, so I'll write them. Reflect across y-axis, right 4, and up 2. There they are. All right. My next point, which is usually on 1, 1, I reflect it across the y-axis. I move it to the right, 1, 2, 3, 4, and then up 1, 2. So let me try that again. Here it is at 1, 1. I reflect across the y-axis. I move it to the right, 1, 2, 3, 4, and then I move it up 1, 2. And so there's my next point. My next parent function point is at 4, 2. I reflect that across the y, so it's going to go to negative 4, 2. I move it to the right 4 units, and then I move it up 2 units. And so there is my new graph. Now for the domain for this one, it is coming from negative infinity, and 4 is the biggest x found on this graph. So we always do the smallest to the biggest here. There is a point at 4, so I'm going to have a bracket. For my range, my smallest y value is 2, and it is going up forever, so that's going to be a infinity sign. All right, let's talk about our minimum and maximum values. A square root function has one or the other. It does not have both. Anytime they ask you for a max or a min, go ahead and sketch a picture. I know it doesn't say to, but it's a good technique for you to see if it's a maximum or a minimum. So I'm going to do a quick sketch. It doesn't have to be exact. I have a reflection across the x-axis here, left 3 and down 2. So left 3, down 2 is right here, and a reflection across the x tells me it is going to face that direction. So this has a max because it goes down forever. So for minimum, I would write none. There is no minimum. It goes down forever. For a maximum, that's your highest point right here. Well, we know this vertex point is these two values right here. So the vertex is found at negative 3, negative 2. And so my max value is that y. The value of the function is the y, the output. And so I would say negative 2 at x equals negative 3. That's where we find our maximum. It is negative 2 at x equals negative 3. All right, so we're going to sketch our picture for this one. It goes to the right one, up 2. There's no reflection, so this is going to face that way. In this case, this has a minimum because it's going up forever. So I would say none for my max. And it's got a minimum. This lowest point is still going to be the vertex. And so the vertex here is 1, 2. And so my min occurs at 2. Right here, the value of the function is the y value. And that happens when x is 1. All right, the next thing you are going to see on the test is really thinking through these functions at a deeper level. So it tells us here writing an equation using the parent function y equals square root of x that has a domain from 3 to infinity and a range from negative 5 to infinity. So again, it doesn't tell you to sketch a picture, but sketching a picture really helps you out. So I'm going to start by sketching this picture. It says my domain is from 3 to infinity. So I know that it starts here and goes in this direction. Now, not just here on the x-axis, but it could be up here that way, or it could be down here that way. Now, the range says from negative 5 to infinity. So we would go negative 5, 1, 2, 3, 4, 5. And this is telling us that it is going up. So we know that it needs to be here, going like this. That means our x being greater than 3 and our y being greater than negative 5. So now we're ready to write our equation. With me graphing this here, I am saying the vertex is at 3, negative 5. So I know in order to get a vertex that's at 3, negative 5, I would say x minus 3 because it went to the right 3, and then minus 5 because it went down 5. If you want to pause the video there and try and do this next one, really think through it, or I'll go ahead and explain it to you. All right, so here we go with our sketch of our picture here. In this case, it says it's coming from negative infinity to -2. So I know our graph has to be coming from that direction there. And this is the biggest x value we're going to find. Then it says a range of negative infinity to +5. So 1, 2, 3, 4, and 5. And it's going to go from up here. This is going to be the highest point down. So we know that our graph has to be up here and it needs to be moving in this direction here. This tells us that +5 is the highest y value and -2 is the biggest x value. So our vertex would be at -2, 5. That helps us write our equation, but we are missing another piece of the information here. In order for our graph to go in this direction, we actually need both reflections. Remember, our parent function goes like this. If I reflect it once, it's going to go this way. And then if I reflect it across the y, it would go this way, which is the direction that we need it to go. So this has to have both reflections. Then x plus 2 to go to the left 2, and then a +5 to go up 5. All right, the last thing we're going to cover is writing the equation from the graph. And so in order to do that, again, you're going to need the transformations. So you know your parent function is 0, 0, 1, 1, 4, 2. So those are always the points that we're looking for here. I can see that this went to the right 2 and up 3, so I know those two transformations already. Then I check my next point to see if I have any stretch or compression. This goes over 1 and up 1, and over 1, 2, 3, 4, and up 2, so there's no stretch or compression. Now I can write, or reflection. Now I can write my equation. I say x plus 2 to go to the left 2, and then a +3 on the outside to go up 3. For this next one, there's that parent function again. So this has gone to the right 1 and down 4 to get to this point here. Now the next point over should go over 1 and up 1. It is clearly not on my graph. And then the next one goes over 1, 2, 3, 4 and up 2. Again, not back on my graph. So, but I can see it's a vertical stretch. And so right here, it went from 2 to going up 4 to get to that point. And here, instead of going 1, it went 2. So these points were doubled. That means I've got a vertical stretch of 2. So I start with that, and then x minus 1 goes to the right one, and then it goes down 4 units. All right, for my last one here, 0, 0, 1, 1, 4, 2. There's my parent function points. So I can see this has moved to the right 5 and up 2. But we also have our double reflection again. If I reflect this over the x-axis, it goes this way. And then if I reflect it across the y-axis from that point, it would go this way. So I need a reflection across the x and the y-axis to get it to go this way. Now, it did go over 1 and down 1 and over 1, 2, 3, 4 and down 2. So there is no stretch or compression. The reflections are the only thing. So now I need it to go to the right 5 and up 2. All right, there's your square root transformations.